Hi, Lynn again. Today we're going to be rationalizing denominators, and we're going to continue the concept of jail, which is getting things out from underneath the radical. So you're going to hear me talk about math gods here. Math gods are people who make up all sorts of rules that we need to follow, and they're sitting out there and they're making these rules, and we have to follow them. And some of them are reasonable. Some of them are we can't divide by zero, and that makes sense because if you put that in your calculator, you get an error. You don't really know what it is. One of the sillier rules in my book is when they say you can't have a square root or a radical in the denominator of a fraction. Well, unfortunately, they're the math gods and we need to follow their rules. So today we're going to figure out how to do that. Now, some of you who have done this before might take a look at it, this first example, 3 divided by the square root of 8x, and just go, oh, I need to multiply it by itself. Square root of 8x, and then do the same thing, square root of 8x on the top. What I'm saying is we don't want to do that because that's too big. We want to fill out jail instead of just blindly squaring it or multiplying it by itself. So we don't want to do that. So what we want to do is break this up. So 8, so the denominator, so we're going to have 3 divided by the square root of 8 is 2 times 2 times 2 times x. Now the object is to get everything out of jail, and this is a square root, so everything needs to have a partner. So we're going to multiply by what the minimum number of things, because we like to keep our numbers small. So we want to take out the smallest, or add the smallest number of things to this to make it so everybody has a friend to get out of jail. So these two can get out of jail. This needs a friend, so we need a 2, and the x needs a friend, so we need the x. And then we do the same thing in the numerator, so we are multiplying by 1. Root 2x over root 2x is 1, and we haven't made it so big. We haven't added extra numbers in there that we're going to have to reduce later. We're saving ourselves some work. So what this will equal is 3 times the square root of 2x divided by, so what does this turn out to be? 1 2 comes out, another 2 comes out, so it's going to be 4x. And that would be the final rationalizing denominator, because now there's no more square roots in this denominator. Now, so we're going to do this a little bit differently. So it's the same idea with a cube root. So in other words, we need to fill out groups of 3 instead of groups of 2. So a knee-jerk reaction would be just, oh, I'm going to multiply it by the cube root of 50. Well, that doesn't make sure that you have enough groups of 3 of everything. So we're going to rewrite this. So it's going to be the cube root of 3x in the numerator. And then we're going to factor that denominator. So it's going to be the cube root of 50 is 5 times 5 times 2. And so we need groups of 3 in order to get things out of here. So we're going to multiply times the cube root because it has to be the same kind of root in order to get them together. So we look and we have 1, 2, 5s. We need 1 more 5. We have 1, 2, so we need 2 more 2s, so times 2 times 2. And so we need to do the same thing in the top. So this is 4 times 5, so this is 20. So these are the same thing. So this is going to be the cube root of 3 times 20, which is 60x, divided by, it'd be 5. 3 5s come out, and 3 2s come out. So it's 5 times 2, which is 10. You're getting this? We only want to multiply the numerator denominator by what is needed to fill out jail and get everything out from underneath the square root or cube root, or in this case a 4th root, because we don't want to have any radicals in the denominator. We'll do one more here. So this is 16 over 9x to the 7th. So we're going to have the 4th root of 16, which is actually 2, because 16 is 2 times 2 times 2 times 2. So I'm just going to write this to save us work, 2 in the numerator, and then I'm going to break this up. So it's the fourth root of 3 times 3, which is 9. And then we have 7 x's. So 1, 2, 3, 4, 5, 6, 7. And we want to figure out what we're going to multiply by. And it has to be fourth roots again, because they need to be matching kind of root to get everything out. So we have 2 3's. We need 2 more 3's. 3, 3. And then we have this group of 4 x's. And then we only have 3 x's here, so we need 1 more x. So we're going to get an x. So this is going to be 9x here. So it would be 2 times the fourth root of 9x divided by, so one group of 3 comes out, and then 2 groups of x's come out. So divided by 3x squared. And sometimes you want to look to see if you can reduce what's outside of the radicals. And in this case, we didn't have that. So that's the final answer for that. So my main tip is to not just blindly multiply this by root 8x over root 8x because it makes it too big. It won't be wrong, but it will make it a lot harder for you, because then when you get down here, you'll have much bigger numbers and you'll have to reduce it. So have fun with that, and I'll see you later.